Notes for asymptotic behavior and curve sketching. Let's go! Hashtag. All right. So here's that function. I want to say that's the same function we used last time. And we're still using the same, we're still doing this with tables. Are we going to use tables all the time? No. But, we're rookies right now, so let's just go ahead. So let's type this expression into our calculators. I'm going to type it into y1. So let me get my calculator in here. And I already forgot the expression. What did I have in the numerator? So alpha y equals, enter 2x squared plus 5x minus 3. What did I have in the numerator? Yeah, denominator. Did I say numerator again? What did I have in the denominator? X squared minus 9. Okay. So let's go ahead. This says to fill in the table. It says, let's approach negative 3 from the left. The notation for this will look like x approaches negative 3 from the left. Let's fill in the table just like we did last time. So it should be approaching that hole there. So if I approach second table, because I already have, I'm going to delete all that. Delete. Second table set if it's not in there. So what's the first value? Negative 3.75? So I'm going to type that value in. And then what's the next one? Negative 3.1. Negative 3.1. I get that. Oh, do you get fractions or what? Yeah. Okay, here's how you fix that. Go to mode and go to where it says fraction type, or actually where it says answers, and put DEC, which stands for decimal. And now push enter. And now second quit. Go back to the table, and now you should be seeing your table in decimals. All right, negative 3.01. It didn't work. Negative 3.001. Oh, because you need a table set. Go second table set. Half. Alright, you get enough negative. Second table set, and then you go to pass to the pencil. There you go, get enough negative. Alright, so in case you're having issues, guys, San Luis Potosí, you doing okay over there? Alright, in case you're having issues, second table set, and you gotta go into independent and put ask. So you can type in whatever numbers. And then I have it for decimal, so it spits out, so it forces my output to be a decimal. And there it is, those are my values. So I'm not going to be able to remember all those, so you guys hook me up. What is it, a negative 3.75? 1.2593. What about a negative 3.1? 1.503? 1.1803. What about a negative 3.01? 1.1681. And then negative 3.001? 1.1668. Perfect. There is a clear pattern here. It is approaching negative 1.16666666666. That is 76. If you take your calculator and you go to their home screen, second quit, and you go 7 divided by 6, you will get that number that it's approaching. See? So there it is. But I don't want you guys to just rely on tables. Now, of course, this is going to be the same thing, right? If I approach negative 3 from the right-hand side, it's going to be numbers smaller than 1.16, but it's going to be still approaching that. So go ahead and approach it from the right-hand side, guys, and tell me what these numbers are. What'd you get? What is it at negative 2.75? 1304. What is it at negative 2.9? 1125?
1525.
1525. What is it at negative 2.99?
1.1653.
And negative 2.999? 1665. And you can see 1665. As you can see, it's still approaching that 1.166666. So, bam. Now, I don't want you guys to, as I was saying a little earlier before I cut you guys off, don't rely just on tables. Make sure that you know how to do it. So, how would you do it? Like this. Watch. Limit as x approaches negative 3 of this function to x squared plus 5x minus 3 over x squared minus 9. And then you would say this. Can I do direct substitution? If I plug in a negative 3 in there, negative 3 squared is 9. 9 plus 9 minus 9 is, can I do direct substitution? No, but notice that I can factor out. So I'm still going to write the word limit. Limit as x approaches negative 3. And in the numerator, I'm going to have 2x and x like so. Now I need to put my 1 and 3 somewhere. Where's my 1 go? Where's my 3 go? Not everyone at the same time. So, and which one's positive? Which one's negative? I need the bigger number to be positive. So this one's plus and this one's minus. Because look, when you distribute, make sure we know algebra, guys. Algebra is the hard part. 2x times x, there's your 2x squared. 2x times positive 3, that's a 6x. Negative 1 times x, that's my minus 1x. Negative 1 times positive 3, there's your minus 3. 6x minus x, that's your 5x, see? And on the bottom, that's the difference of squares. I can rewrite that as x plus 3, x minus 3. Notice I have a common factor. This is the product on the top. The bottom is also a product, but I'm dividing. So multiplying and dividing is inverse operations, right? So something cancels. What cancels? The x plus 3 will cancel out. And notice, can I do direct substitution now? Yes, now you can. 2 times negative 3 minus 1 over negative 3 minus 3. So let's see what that is. 2 times negative 3 is negative 6. Minus 1 is negative 7 over negative 6. Negative divided by negative is a, and OMG, we get that 7/6 value that we wanted. So we're not going to be doing this whole table things over and over and over again. But if it helps and you want to do it, one at a time like that, yes, you can. Are we cool? Okay. So now let's talk about, let's see, well, this one it says we conclude that the limit is 7/6. All right. Next page. So now we're going to approach infinity. I'm not a big fan about approaching infinity with tables because I can just look at the function. So you should already see, what am I approaching? Negative infinity? Yeah. You can see that if you approach negative infinity, I'm going to be approaching what value? 2. So I just want you guys to see it, just so you guys can start buying into it. Remember, that's the same thing as horizontal asymptote. So we're going to be talking about our horizontal asymptote rules in a little bit. So let's check it out. I go to my table, and no yawning, that's a demerit. Now, you know how we do it here. YouTube, I'm not giving demerits out for yawning. But they shouldn't be yawning. They're saying that math is boring. I'm kidding. Should I delete that out? We'll see. All right. All right, let's put negative 50. Push enter. And I get that number, 1.9057. What do I have next? Negative what? Negative 100. And look, push enter. And I get 1.9515. What do I got next after that? Negative 500. Enter. And I get 1.9901. And then what do I have next after that? Negative 1,000? Negative 1,000. And I get 1.995. What is it approaching? 2. Right? So hook me up with those numbers. Let me go back to my thing here. Hook me up so I can have good notes here.
1.9057.
Okay.
1.9515.
9515, okay.
1.9901.
9901, all right.
1.995.
Good. This looks like it's approaching 2. And don't worry, we'll talk about the rules in a little bit, just in case, for polynomials. we're going to do the same thing, but we're approaching positive infinity here. So again, I think it was, if I looked at my graph, it looks like it still approaches 2. It looks from above though, so it's going to be larger numbers than 2, but it's still going to be approaching. So I'm going to delete those, delete, and I'm going to put the same thing, 50, 100, what else did I use? Did I go 500? And then 1,000. And check it out. Again, what number does it look like I'm approaching? 2. So I can have good notes. Hook me up with what I wrote for each one. 1064, 0515, 0101. Ooh, binary. 005. Okay. So this is approaching 2. How do we feel? All right. Now we have a vertical asymptote at 3, if I remember correctly. Let's see. Yep. So we have a vertical asymptote at 3. So we can't do direct substitution because we get a 0 in the bottom. Even for this, even for what we have left, we can't, we plug in a 3 in there. 3 minus 3 is 0. See? If you get a number divided by 0, it's probably a vertical asymptote. So let's see what happens. Look, as we approach 3 from the left-hand side, if we approach 3 from the left-hand side, I'm going to be approaching a negative infinity. You guys see that? So that's what's going to be happening. So let's approach 3 from the left-hand side using these numbers. So I'm going to come back. I'm going to push delete. Delete. So what did I use first? 2.75? 2.75, push enter, and I get negative 18. What do I use next after that? 2.9, push enter, and look at that, negative 48. And then I guess, do I use 2.99 next? And then 2.999. And there it is. Look how that number is not converging. The magnitude is getting larger, but in the negative direction. Do you guys see that? Okay, so hook me up with those values. Negative 18, negative 48, 498, 4998. Okay. So here's how we're going to think about this from now on when we know we have a vertical asymptote. If we already know we have a vertical asymptote, if we're approaching from one direction, it's either going to approach positive infinity or negative infinity. So we're gonna have to talk about the behaviors of how do we get positive infinity, negative infinity. Don't worry, we'll talk about that. All right, we're doing the same thing, but we're approaching from the right-hand side. As you can see, if we're approaching from the right-hand side, it should be positive infinity. So let's do that really quick. 3.75, 3.1. So I'm gonna delete. 3.75, enter, and then I think I do 3.1, and then I think I do 3.01. and 3.001. That number is not converging. It just keeps getting larger and larger and larger. So hook me up. 666. Okay, 7. Next one. 52. 502. 5002. And then this is approaching positive infinity. The other one was approaching negative infinity. How do we feel, guys? Nothing crazy, right? All right. So it says here, observe asymptotic behaviors. I can't even talk today. Observe asymptotic behavior. How are limits related to asymptotic behaviors? So here's how limits are related. If if x is approaching c from either the left-hand side or the right-hand side of some function, and you get a positive infinity or negative infinity, it's a vertical asymptote. Positive infinity or negative infinity, that means you have a vertical asymptote at x equals c. Same thing with this one, positive infinity or negative infinity at vertical asymptote at x equals c. I don't have enough room for my horizontal behavior. Don't worry, I'll put it here. I'll put it in the top. Does that make sense, guys? Okay. If my limit as x approaches infinity, that's an infinity. It just came out weird. Let me write it back. So let me see if I can cut it and pretend this line's not there. If my limit as x approaches infinity of some function equals a constant, then that means that constant is a horizontal asymptote. at y equals L. Let me write the other one because that's positive infinity. I could also approach what direction? Negative infinity. So write the other one as well. Limit as x approaches negative infinity of some function. If that equals L, that means I have a horizontal asymptote at y equals L. Yes. A number, some number, 2, 3, 5, 11, 100, pi. It's just some number. L is a constant. And I'll put that here. L is a constant. I guess technically, I wanted to use L for limit. No, I didn't. I'm not sick. If anything, you guys got me sick. All right. Here we go. Quick lesson on horizontal asymptotes. It is only for polynomials. Remember these rules that they give to you in Algebra 2, but you don't have to memorize them, guys. Just do common sense. We're talking about end behavior. If you spit in the ocean, does the ocean rise? No. So all you got to do is identify what is ocean in the numerator and denominator. What is ocean? Whatever has the highest degree. Does that make sense? All right, so I'm not going to do these top ones just yet. I'm going to start at F. Don't worry, we're going to do all those. So look at F. What is x approaching? Infinity, so that means I'm looking for end behavior. My spit in the ocean. On my numerator, what is the highest degree? It's a square. When you multiply all that. What would be that my coefficient? A 7x squared in the numerator. Do you guys see that? What is my ocean in the denominator? X squared. So 7x squared over x squared. What's my end behavior? 7. That's my limit. That's also your horizontal asymptote. Do you see how we did it, guys? We're going to do it again. Don't worry. So check it out. Look at letter G. What is ocean in the numerator? The 5x. What is ocean in the denominator? Well, there's only one term. The 2x squared. As x approaches infinity, what is growing faster? The denominator or the numerator? The denominator. So what is this going to approach? You guys know? Okay, I'll help you out. Don't worry. What's 1 divided by 1? 1. What's 1 divided by 10? 0.1. What's 1 divided by 100? Notice that the denominator is getting bigger. 0.01. What's 1 divided by 1,000? 0.001. What do you notice as the output is happening? What is happening to the output? It's getting smaller. It's getting closer and closer to 0. So that's exactly what happens with this. If the bottom grows faster than the top, you're going to be approaching 0. So let's start again. So is my denominator bigger than my numerator, the degree? Yeah, so that means my denominator is growing faster than my numerator. So all this is going to go to 0. See, and now you don't have to memorize rules. You're just doing it with your big brain.
I never understood why the blue always had 0.
Yeah, because, yeah. Well, they should have taught it from the beginning like that. But I'm not, okay. Because, we're not robots here. Now, notice in letter H, 5x cubed is the highest degree. And 23x squared is the highest degree in the denominator. What degree is higher, the one in the numerator or the one in the denominator? Numerator. Because the numerator is larger than the denominator, this is undefined. It's not going to converge. It's actually approaching infinity if you want to be specific. Does that make sense? Because it's like saying this. 1 divided by 1 is 1. 10 divided by 1 is 10. 100 divided by 1 is 100. And I know that I'm keeping the denominator the same. But it's that behavior. The numerator is getting bigger than the denominator. So it's just going to be getting bigger and bigger and bigger. Cool or not cool? Okay. Look at letter I. What's my ocean in the numerator? 7x cubed. What's my ocean in the denominator? All right. So 7x cubed divided by 2x cubed. As x approaches infinity, what is that going to approach? 7 over 2. Yay or nay? Yay. All right. Let's look at letter J. Hey, relax. You got to just go one at a time. You just have 5x in the numerator, and that's it, right? In the denominator, look first at the square root of x squared plus 1,000. X is approaching infinity, so as x gets really, really large, the x squared is what is ocean, right? What's the square root of x squared? X. And then we don't care about the 24 because that's insignificant. So what's 5x divided by x? 5. Now let's think about this one here. It's the same expression, but now I'm not approaching infinity. I'm approaching what? Negative infinity. So think about it. 5 times some large number, but negative. So negative large number, large hashtag, divided by, if I'm squaring that large number and then taking the square root, is that going to be a positive x or a negative x? Positive, because I'm squaring. So it's the same magnitude, but positive. Positive large. So what am I going to have here then? A negative what? Negative 5. How do we feel? Ask. Yes. You see how I'm approaching negative infinity? So if I were to be approaching, remember this 1,024 is spit, so it's not significant as if you spit in the ocean, it's not your ocean, right? So this x squared, so it's like saying this, 5 times negative 100 divided by the square root of negative 100 squared. Well, notice I'm squaring it first. So if I square it, that would just be 100 squared, and then square root of 100 is just 100. So it would just be 5 times negative 100 divided by 100. And then what's positive times the negative? No, positive times the negative is a negative, right? Okay. And then the 100s just cancel out. Do you know what I mean? So it's the same number. These numbers are just canceling out. One's positive, one's negative. The one in the top is negative. The one in the bottom is positive because of the x squared. You know what I mean? Does that make sense or no? Yeah. All right. How do we feel, guys? Okay. So now here we go. Let's go back. I'm going to go into the top here where there's space because there's still a whole bunch of limits that we haven't talked about. Do you know how this function looks like? Do you guys know how e to the x looks like? Oh, man, guys. All right. E to the x looks like this. So let me change my colors. Y e to the negative x. Remember, e is just a number, 1 point something, 1.69, or e to the negative x is going to look like this. Yay or nay? All right, what else do we got to know? ln. Y equals ln of x. That has a vertical asymptote at x equals 0, and it crosses the x-axis at 1, 0. And there are reciprocals of this, 0, 1, and 0, 1. Are we okay? Okay, so now let's see if we can figure this out. Limit as x approaches negative infinity of e to the x. What do you think it is? It's not negative infinity. 0.
Oh.
If I approach, look, it's e to the x. It's this one right here. I have a horizontal asymptote at y equals 0. If I approach negative infinity, I'm approaching the y value of 0. Do you guys see that? Okay, let's go to the next one. Limit as x approaches infinity of e to the negative x. E to the negative x, what is that? It's 0 as well. Cool or not cool? All right, what about limit as x approaches infinity of ln of x? What does that look like? Does it look positive infinity? It's going up forever. Very slowly, but it's going up forever. Don't look at my boogers.
Okay.
I don't think I have a whole bunch. Let me check though. Sorry, miss. All right. Are we okay so far? All right, letter D. Limit as x approaches infinity for ln of x. So remember, This one's already going, as x approaches infinity for ln of x, that's already approaching infinity very slowly. So this is just getting larger and larger very slowly. And it's ln of that. So it's growing even slower, but am I still approaching infinity? Yes, just very slow. Very slow. But you're still approaching, just very slowly. Yay or nay? Okay. Look at this. Don't get tricked. All of them look the same regardless of, especially if it's, yeah, it says negative 0.001 to the x, but it's still, e to the negative x looks like this one. Are we okay? All right. So this one here, this right here, I'm approaching positive infinity. That looks like 0. So it's 1 over 2 plus 0, which is? Okay. Yeah, just what I circled. This, just what I'm circling in black. That is 0. Yes or no? So then I have 1 over 2 plus 0, which is just? Are we getting okay? Don't worry, guys. We have a visual to help you. I thought it out, so I have an activity. What about vertical asymptotes? What about them? Oh, yeah. We already talked about them. Okay, just an idea. I'll just put a simple one here. Limit as x approaches 3 for 1 over x minus 3. Notice there's nothing you can do. I can't do direct substitution. Hopefully you remember how 1 over x minus 3 looks like. If you don't, it's okay. At 3. And if you approach from the right-hand side, it's going to approach positive infinity. If you approach from the left-hand side, it's going to approach negative infinity. Chavez, how do you know that? I know. How do you know that it's going to look like that? Let me show you. If you get a number over 0, it's going to be a vertical asymptote. So now, when you approach from the left, how do you know it's negative infinity? Well, think of a number to the left of 3, like 2.9, 2.99, 2.999. Does that make sense to you guys? 2.9 minus 3 is a negative number, negative 0.1, right? If I use 2.9. If I use 2.99, that's negative 0.01. So 1 divided by, remember what I said, 1 divided by negative 1 is negative 1. 1 divided by negative 0.1 is negative 10. 1 divided by negative 0.01 is negative 100. 1 divided by negative 0.001 is negative 1,000. Does that make any sense, guys? So I already know if I approach from the left, it has to be negative infinity because I'm dividing 1 by a very, very small negative number. So I'm going to write it here. Limit as x approaches 3 from the left of 1 over x minus 3 is negative infinity. What about if I approach from the right? Limit as x approaches 3 from the right of this function. Well, it has to be positive infinity because I'm doing 1 divided by a really, really small positive number as I get closer to 3. If I choose 3.1, 3.1 minus 3, 0.1. If I choose 3.01, 3.01 minus 3, 0.01. So 1 divided by a really, really small positive number, boom, huge number. Cool or not cool? Okay, and of course this one, since the behavior is negative infinity and positive infinity, you would say does not exist. The limit does not exist. How do we feel? Okay. It says here, find all vertical asymptotes of the graph. Justify your work by showing limits. At the time when I wrote it, I thought this was a cool question, but now that I'm looking at it, it's not very good. Just show, how would you find vertical asymptotes? I would expand it. So in the numerator, can I factor this one out? Yeah. X plus something and x plus something. What is that something? 2 and 3. 2 times 3 is 6, and 2 plus 3 is 5. So make sure we know how to factor, guys. If we have issues with factoring, it's going to be kind of hard to do this. In the denominator, I can factor out an x, and I want you to notice that I'm going to have x squared minus 4. Now, before you leave it alone, x squared minus 4 is the difference of? So I can expand this to look like this. X plus 2, x minus 2. what factors do I have that cancel each other out? So that's where I have a what? Not a vertical asymptote. That's where you have a hole. So at x equals -2, you have a hole. If you have a hole, you have a limit. If you have a hole, you have a limit. All right. The hole, the ones where you cancel it, that's where my hole's at. So when it zeroes out, -2 plus 2 is 0, right? You know what I mean? Okay. Because that's my domain does not include 0, -2, and +2. All right, I cancel out my factors. All right, now that means I have 2 vertical asymptotes because this I couldn't cancel and this I couldn't cancel. So I have a VA at x equals 0 and another one at x equals 2. How do we feel? All right, that's it. You can't divide by 0. How do we feel, guys? Do we feel okay?
Yes.
All right. Number 3. We're going to do these together. Espinosa, we're doing it right? Okay. I'm approaching negative infinity. Will the numerator ever be negative? No. Why? Because I'm taking the what first? I'm doing the square first and then taking the square root. Does everyone see that, guys? We're doing the square first and then square root. So what's my end behavior for the numerator? 8x. That's my end behavior. It's always positive. Are we okay? The square root of 8. Square root. Okay, sorry. X square root of 8. And that's always positive. Does everyone know why I did it that way? No? Okay. Okay, slow down. My end behavior for the 8x squared minus 4x, it's the 8x squared that's my ocean. The 4x is insignificant. So you have the square root of 8x squared. But x squared is a perfect square. That's x squared. So the square root of x squared is x, and you just have the square root of 8. Cool? Or not cool? Yeah, the square root and squared cancel each other out, so it's just x. The x is what's being squared, not the 8. It's not this. It's not 8x squared square root of that. That would just be 8x. It's just the x that is being squared. So it's x square root of 8. You know what I mean? Okay. Over in the denominator, the x is my end behavior, but x is approaching negative infinity, right? So I'm going to write that as negative what? I'm going to write that as negative x. Because it's going to be a negative number. Does that make sense to everyone? What's going to cancel out? And I know what you're saying, Chav, I don't see the answer in there. It's in there. Square root of 8, negative square root of 8, because I brought that negative up. Yeah. 4 times 2, so that's negative 2 square root of 2. How do we feel? Yeah, these are hard limits, guys. What's up, Rodriguez? You had a question? Okay. Okay. Look at this one. ln of 1 is 0. ln of 1 is 0, guys. So I can't do direct substitution. If I do direct substitution, I get 1 divided by 0, so I definitely have, it's a vertical asymptote. A number divided by 0, I'm going to have a vertical asymptote. All right, is it positive infinity or negative infinity? So everyone should be thinking in your head, it's definitely a vertical asymptote. Chav, how do you know it's a vertical asymptote? Remember what I told you. If you do direct substitution, you get a number divided by 0, you have a vertical asymptote. If you get 0 over 0, you have a limit. You got to find it. If you get 0 over 0 with direct substitution, you have a limit. So find it. If you get a number over 0, then it's probably a vertical asymptote. And it does not exist. If I had the answer choice does not exist, I would answer that. But there's no does not exist. So I either got to choose between negative infinity or positive infinity. Do you remember how ln of x looks like? Looks like this. And remember that I cross it at 1, 0. What am I approaching 1 from? The left or the right? So think about it. If I'm no, not from the right, from the yeah. If you're approaching 1 from the left, I'm looking at this graph right here. This is my LN graph. If I approach 1 from the left, am I going to have numbers that are really, really small in the negative direction or the positive direction? Yeah, in the negative, right? Negative 0.1, negative 0.001, negative 0.00001, the y values. So 1 divided by a really, really small negative number is going to be negative infinity. Yes. Natural log. Natural log. It's just a function, logs. It's log base e of x. Ln x is log base e of x. Right.
At this time, and we can transition to fourth.
Hold on, guys. Hold on.
Again, we can transition to fourth period.
What do you got fourth? Yeah, you don't want to go there. All right, real quick. Just this one last question. No, you can tell her that I said it. One last question. 2 times 2 minus 4. You can't do direct substitution, correct? But notice that I'm approaching from the left. So I get a number over 0, so I know that's a vertical asymptote. So scratch, scratch. It's either A or D. If I approach from the left, so I'm talking about numbers like 1.9, 1.99. 2 times 1.9, is that a number bigger than 4 or smaller than 4? Smaller. So some number minus 4, that's going to give me a negative number, right? Positive divided by negative is a negative. Do you see how we did it? All right, we're done. We'll continue it next period. All right, guys, let's continue, guys. Take out your notes. Here's where we left off. I'm going to go over this one slowly again because we went kind of fast through it. I think you guys will agree. All right, so here we go. If you're on the process of getting it out, I think you'll be fine. You'll catch up really quick because you already answered it. So on this one right here, limit as x approaches 2 of 5x plus 1 over 2x minus 4. You notice that you can't do direct substitution because if you tried direct substitution, you would get 5 times 2, 10, plus 1 is 11. And on the bottom, you get 2 times 2, which is 4, and 4 minus 4 is 0. So I get 11 over 0. If you get a number over 0, it's probably a vertical asymptote. Let's see which. So immediately the first two that you should delete are B and C. So I know for a fact it's either going to be positive infinity or negative infinity. I want to know which one it is. So here's all you got to do. All you got to do is figure out if the bottom is negative or if the bottom is positive. If it's positive, I know that 11 is a positive number. Positive divided by positive is positive infinity. If it's negative, the denominator is negative, then positive divided by negative is going to be negative infinity. So I'm approaching 2 from the left, so give me a number from the left of 2. Okay, 1. 2 times 1 is 2, and 2 minus 4, that's a negative number. Do you guys see that? Give me a number closer to 2, a little better than 1, but closer to 2 from the left. 1.9. 2 times 1.9 is a number close to 4, I don't know, maybe 3.9. And then 3.9 minus 4, negative 0.1, or negative, do you guys see that, negative 0.1? If I choose a number like 1.99, 2 times 1.99, that might be 3.99. I mean, I don't know, something like that. 3.99 minus 4, negative 0.01. See, so a positive number divided by negative 0.01, negative infinity. Shove, I don't see it. I'm gonna choose the number 1. I'm gonna leave it at 1. 1 divided by 1 is 1. I know, okay, let's do a negative. 1 divided by negative 0.1, negative 10. 1 divided by negative 0.01, negative 100. 1 divided by negative 0.001, negative 1,000. Do you guys see what's happening? How you're just growing without end? Cool or not cool? Are we happy? Okay, let's go to the next question, guys. All right, so these are practice. This is what we should already be really good at. We should, technically. You guys ready for this? All right, 1 minus secant squared. I'm going to go to the side, and I'm going to write cosine squared theta plus sine squared theta equals 1. Yeah, that's a side note. The only way to get secant squared is if I divide everything by cosine squared. Oops, I already had a division symbol there. So I get 1 plus tan squared theta equals secant squared theta. Yay or nay? I'm going to switch these two guys. 1 minus secant squared theta is equal to negative tan squared. And that's what I'm going to use. So I'm going to write limit as x approaches 0 of negative tan squared. And I got to keep the argument the same. 6x over, and I'm going to square this. I'm going to write 4x squared. Are we still okay? Okay. Remember, we have a special formula. Sine x over x is equal to 1, and so is... Oh, man. Yeah. Limit as x approaches 0 of sine x over x equals 1, and so is limit as x approaches 0 of tan x over x. It doesn't have to be x. It's a 1. It could be happy face x over happy face x, but they have to be the same. So I got to keep this argument. I have an argument of 6x. So here we go. I'm just expanding it. Limit as x approaches 0, negative tan of 6x over one of those x's. Remember, that's 4x squared times tan of 6x over one of those x's times 1 over 4. It's all this here, not to be confused with whatever I have on the side there. So that's the same thing as what I have on the left. Are we okay? I haven't done anything crazy, right? All right. So here's what I need. What does this first one need in the bottom? If I put a 6 in the bottom, I got to put 1 in the top. A 6. So there's my 6 on the top. Cool or not cool? What does the second term need? Or second whatever? Another 6 in the bottom. If I put a 6 in the bottom, I got to put a 6 on the top. I'm ready. So this turns to negative 1, because that's negative 1 right here, times 1 times 6 times 6 is 36 over 4. Yeah. 36 over 4 is equal to 2. 9, but I remember the negative in the front, so negative 9. How do we feel? Nothing crazy, right? So there's your pre-cal. That's why you need pre-cal to be in cal, so you can do that type of stuff. Are we okay? Okay, so here we go with the next one, guys. Limit as x approaches 0, 3 over 4x cosecant 3x. Can I do direct substitution? Can I do? No, you can't. Chav, I'm done then. I don't know what to do. Relax. Cosecant is the reciprocal of sine. So if I have this on the, so here's what that means. 1 over cosecant x means sine x, because they're reciprocals of each other. The cosecant's in the bottom. Now sine x equals 1 over cosecant x. Cool or not cool? So that means I can rewrite this limit. So here's a little bit of pre-cal. 3 sine 3x over 4x. Am I cool? Equals, here we go. I'm going to expand it. Limit as x approaches 0. Giant parenthesis. I'm going to write the 3/4 together times sine 3x over that x times, no, I don't need another. That's the same. And I'm going to change colors. Whatever is in different color is what I'm adding. Are we okay so far? That's a 3 there, in case we're wondering. What do I need in the bottom, right here next to that x here? A 3. So if I put a 3 in the bottom, what I got to put at the top? Another 3 to balance it out. So now I have 3 times 3, which is 9 over 4. And then sine 3x over 3x, as long as x approaches 0, is going to equal 1. So this gives me 9/4. How do we feel, guys? Anything crazy? Okay. And let's go to number 8. All right. So this one, we can do direct substitution again because we get 0 over 0. If you get 0 over 0, it has a limit. It has a limit if it gets 0 over 0. So here's what you're going to do. Multiply by the conjugate of what you want to get rid of. I want to get rid of the 1 minus cosine, so I'm going to multiply this by 1 plus cosine 2x over 1 plus cosine 2x. When you do that, you're going to get limit as x approaches 0 And I'm not going to distribute this. I'm going to leave it like this. 5x squared, 1 plus cosine 2x. There's a reason for why I'm going to leave it like that. You'll see right now. All over, and then the bottom turns to 1 minus cosine squared 2x. Do we have any questions on how we got to here? Please let me know because I can't read minds. This is like the difference of squares, right? 1 minus cosine, 1 plus cosine. So it just turns to a squared minus b squared. So 1 minus cosine squared. If you want to distribute it longhand, that's fine. The middle terms will cancel out. Cosine 2x minus cosine 2x plus cosine 2x. Are we still okay? This right here, before I continue, are we okay so far up to here? Okay. 1 minus cosine squared 2x is the same thing as what? Perfect. I heard someone say it. It's the same thing as sine squared x, guys. That's why we took pre-cal. So here we go. Limit as x approaches 0. And I'm going to write 5x squared, parenthesis 1 plus cosine 2x over sine squared of 2x. You got to keep the same argument. I now have 5x squared, 1 plus cosine 2x times sine over sine squared 2x. So I'm going to write it like this. I'm going to expand it, limit as x approaches 0, giant parenthesis. I'm going to write it like this. X over sine 2x times x over sine 2x times, let's see, what have I not used? 5 parenthesis 1 plus cosine 2x over 1. That's fine. That's the same thing. I know, guys, it can be hard, but it's kind of like a little puzzle. You get better the more you use it. I'm going to use a different color. What am I missing on this one right here? A 2. If I put a 2 there, I got to put a 2 where? In the bottom. I'll put the 2 right there in the bottom on that one. So it doesn't mess with this one. What am I missing on this middle term here? Another 2. So if I put a 2 there, I put a 2 in this one like that. See? So now we're ready, guys. Now we're ready. I'm going to zoom out. Equals, this is 1 times that's another 1 times cosine of 0 is not 0, 1. Cosine of 0 is 1. 1 plus 1 is 2. 2 times 5 is 10. Divided by 2 times 2 is 4. So there it is, 10 over 4. That reduces to 5 over 2. How do we feel? Do we feel okay? In a little bit, we'll have a lot of fun. Don't worry. We're going to have a lot of fun right now with exponentials. All right. I know, guys, it's warm in here. And if you're feeling under the weather, it's starting to become unbearable. I apologize. Can I do direct substitution with this last one here? Yes. Just do direct substitution. Limit. Well, I guess if I'm going to do direct substitution, I don't have to write word limit anymore. Cosine 9 pi over 4 minus 1 over 6 times 9 pi over 4. Do you remember what cosine 9 pi over 4 is? Yeah, it's like pi over 4. Good job, Lavelle. 9 pi over 4 is like pi over 4. Those are what you call coterminal angles. 8 pi over 4 is 2 pi. So you just did a whole revolution, and then you went up another pi over 4. So cosine of pi over 4 is square root of 2 over 2 minus 1. And then, let's see, I would reduce this 2 and 3. 27 pi over 2. I'm going to turn that 1 into 2 over 2. So I'm going to erase that. I'm going to put 2 over 2. And here's what I'm going to write. Square root of 2 minus 2 over 2 times 2 over 27 pi. The 2's cancel out. And I have square root of 2 minus 2 over 27 pi. Ask questions, guys. Ask questions, guys, because I can't read minds.
Wait, what's the very last part? The small part?
2. I just did keep, change, flip.
Oh.
Are we cool, guys? Okay. The more you practice, the better you get. See, this is all trig, and some of you guys got hundreds on that one right off the bat on that UH quiz. So that's why I was kind of like, man, you guys are super beasts. I'm going to ask you these same questions on the exam, guys. So I think we'll be ready for an exam next week. Limits exam. We should be ready for one next week sometime. All right. Do you guys know exponential functions? Like how they behave? If you know how exponential functions behave without a calculator, you will be fine. So can you tell me, so hopefully this is fresh because we did it this morning, y equals e to the x. Do you know how that function looks like? Yeah, it looks like this. What about y equals 2 to the power x? Do you know how that function looks like? It looks exactly like e to the x. The only difference is that 2 grows a little faster when you approach left to right. I know I didn't make it look exactly the same. It grows a little faster because 2 is a little bit bigger than e. All right, here we go. Here's what I want to know. Do you know, and don't be a robot. Do you know the Muffin Man? That's funny. Do you know how y equals 1/2 to the x looks like? How's it going to look?
Rise over rise.
No. Does it look like these two? Kind of.
Is it gonna be like it's gonna grow but wider?
Okay. All right, guys, let's stop. When you take a decimal or number between 0 and 1 and you square it, do you get a smaller number or a bigger number? You guys never done it? Okay. Okay, when you take a number between 0 and 1 and you square it or multiply it by itself, it gets smaller. 0.5. When I square it, 0.25. 0.5. When I raise it to the third power, 0.125. Do you see how? Yes. So do you see how as you raise the power, it just keeps getting smaller and smaller? So look, let's not be a robot. This looks like this. But only because this number, the 1/2, is between 0 and 1. If that number would have been 1.5 or 1.8 or 2.3 or 2.4, it would look like these. Because as you raise a number that's bigger than 1 to a power, it's going to be a bigger number. 2.1 to the third power. I don't know, but I know it's big. 2.1 to the fifth power. I mean, I can probably give you an approximate, but since I said 2.1, does that make... Okay, let's just choose 2 because 2 is simple. 2 to the second power, 4. 2 to the third power, 8. 2 to the fourth power, 16. 2 to the fifth power, 32. 2 to the sixth power, 64. 2 to the seventh power, 128. Do you guys see what's going on? So, it's the same with this. The math works the same for everything, guys. If I have a fraction, like 1/2, technically this is like saying 2 to the negative x. It's like saying that. See, look at this. If I were to write y equals e to the negative x, you guys know that it looks like that now. Well, look, 2 to the negative x looks like 1/2 to the power x. Because laws of exponents, when you guys were in algebra, if someone told you 2 to the power negative 1, you would immediately do that. And if I do that, well, a power raised to a power, that just means 2 to the, see? So all of it's connected, guys. Are we clear? Okay, so that's what's going to help a lot. All right, so let's talk about these right here. 2 to the power negative x. How's it going to look without an assistance of a calculator? Like that. Cool or not cool? All right. E to the x minus 4. Instead of having a horizontal asymptote at the y-axis, you make a shift 4 down. And there's my horizontal asymptote. And now this guy looks like this. So now if I tell you what's the limit as x approaches negative infinity for e to the x minus 4, you would tell me negative 4. Are we okay? Okay. Negative 2 to the power x. Well, 2 to the power x, okay, don't write this down, just listen. 2 to the power x would look like that. But if I put a negative in the front, all that does is reflect it across the y-axis. Good. So it's going to look like this. Do we see it, guys? Did I say y-axis? Okay, x-axis. It reflects across the x-axis. It's negative, so it reflects across the x-axis. My bad. I'll make sure to tell my YouTube fans about the error there before I correct myself. Across the x-axis. It reflects across the x-axis. Cool or not cool? Let me make them time set. 319, remind me. Okay. All right. Can you do these questions without graphing? So maybe, remember your activity? Go to your activity. Because I think it might be a little easier. I fixed it here, but I didn't fix it on yours. On yours, I think it still says activity 4. Fix that activity number and put activity 3 because it's not activity 4. Go to, is it the last page? Second to the last page. So look at this, guys. 2/3 to the power x minus 1. So that was a shift 1 to the right and then 1 down. But we don't really care about that unless we're going towards this specific value, 1, negative 1. So don't worry about shifting left or right. What we should really be worried about, especially for end behavior, because everything's approaching infinity. So what we should really be worried about is what's happening as you approach negative infinity and positive infinity. All right, look at this. That's 2/3. It's a number less than 1 to the power x. So it's going to look like this. Do you guys see that? That minus 2 is a shift down 2. So I have a horizontal asymptote at negative 2. So what's my limit as x approaches negative infinity? No, positive infinity, right? If I approach negative infinity, doesn't this graph go up? Okay. What's my limit as x approaches positive infinity? That one's negative 2. How do we feel? Okay. Look at the next graph, the one on the right. That's a 3/2 raised to the power x. 3/2 is bigger than 1. So if you raise it to the power x, it's going to be growing as x gets larger. Does that make sense? Okay. As x approaches negative infinity, what is my horizontal asymptote? It's whatever this vertical shift is. It would have been y equals 0, but because of that minus 2, it brought it down 2. So my negative infinity is going to approach what value? Negative 2. As I approach positive infinity, it's going to approach positive infinity. How do we feel? I know, guys, it's really warm in this room. When it's really hot, especially if you're coming down with something, it's going to be really hard to concentrate. But try your best. Are we still okay? Okay. Here we go. We have half. Don't worry about the negative for now. We'll talk about it in a little bit. Pretend that picture is not there. Pretend. 1/2 to the power x. Well, 1/2 to the power x would have looked like this. Where's my x-axis? It would have looked like that. And then this minus 1, what does it do? It shifts it down 1. But now that I have a negative, remember that reflects across the x-axis. So now it looks like this, you see? So now let's see. As x approaches negative infinity, what is this? You could also say it does not exist, but negative infinity. And as x approaches infinity, what is it? Negative 1. Do we see how we're doing it, guys? Okay. Notice I have 1/2 to the negative x. So that would have looked, without the shift, obviously it moved to the, let's see, negative. So it went to the right 3 and up 2. But without the shift, it would have looked something like, let's see, it would have looked something like that. Cool or not cool? With the negative there, it reflects it across the x-axis, and then that plus 2 is a vertical shift up 2. Okay, so I think we're good. I think we're in the right direction. If I approach negative infinity, what is this going to approach? 2. That's that shift there. If I approach positive infinity, it's going to approach negative infinity. You could also say it does not exist. All right. Now that we've done those, should we go back to the notes? All right, let's see if we can do these four. All right, don't worry. We'll talk about that x minus 1 or minus 1 later on. Right now, all you got to focus on is the 2/3 and negative x. So I'm going to put it right here. Y equals 2/3 to the negative x. Is that 2/3 smaller than 1 or bigger than 1? Smaller. So, okay, for now I'm going to write a positive x because I want you guys to really know this. If it would have been 2/3 to the positive x, it would have looked like this. Because as x gets larger, my y values get smaller, right? But I have a negative x. So that means that as x gets larger, my y values are going to get larger as well. Yes or no? Because remember, that negative x is really like saying 2/3 to the negative 1 raised to the power x, which is really like 3/2 to the power x. But did I say that too fast? Okay. 2/3 to the negative 1 to the power x. Well, look, 2/3 to the negative 1, that's going to be 3/2 to the power x. Okay, you guys don't believe me. Let me go to the calculator so you guys can see. So look. It's negative 1, it just... Yes. So check it out. I'm going to go ahead and put, you know how earlier we did auto? I'm going to put auto or, ask. And I'm going to put, what am I going to put? I guess I'll make up my own. I'm going to put, just so you guys can see that they're the same, 1/2.
So are they opposite reciprocals or is that like...
Don't say opposite, they're just reciprocals. Yes. And I'm going to put it to the negative x. And then this one here, remember this is like saying 1/2 to the negative, like see that negative 1 and that negative x? That's like if I would have said 1/2 to the negative 1 raised to the power x. So 1/2 to the negative 1, that's just 2. So 2 to the power x, these are going to have the same table values at every value. So check it out. Second table. And look at this. Look at that, guys. Different equations, but look at the y values. They're the same at every single one. See, this is why I tell you guys that I don't want you guys to be robots. It's not your fault. It's not anyone's fault. I'm not blaming the I'm not even blaming the teacher because we're all, everyone's trying to do their best. But sometimes we just hand you stuff like, oh, just read these directions. Guys, if you understand what's happening, you don't ever have to memorize anything because you know the concepts of it. Does that make sense? So if I tell you 2/3, let's do that 2/3 one. So we can see, watch. Alpha fraction, enter 2/3. And I'm going to raise it to the power negative x, because that's what power negative x. And then watch. This one here, I'm going to change this one to 3/2. What was that? Who was that? Was that Wiersberg? She sounded like a grandma there. I mean it with love, guys. Don't go over there and watch. Check it out. Second table. It's in the. Look for my little folder. It's in there, and I already did it.
Okay, though. Actually, it makes a lot of sense. Boy, what folder? This one?
No, it's a little notebook.
Guys, look for a little notebook.
Oh, here it is.
Okay.
Take it.
Grazie. What's my...
Do you see how they're the same, guys?
Yes.
Okay, so let's see if we can understand the concepts. I know it can be hard, especially if we never understood it. Okay. So 2/3 to the x would have been this graph here, but I have a negative x, so that's like 3/2 to the x. So it's going to look like this one in sky blue, right? And then the negative reflects it across the x-axis. So then what does that minus 2 do? Just vertical shift down 2. So what do we say this one looks like? This one looks like the one in sky blue. So if I approach positive infinity, this one's going to be what? Is it going to be -2 or is it going to be positive infinity? Positive infinity. Do we see how we did it?
So whenever the x is negative, you're reflecting with the x
Oh, there is no negative on this. It just, I don't know why I said negative. The only negative that there is on this guy.
Yes, whenever the exponent.
Whenever the coefficient in the very front is a negative, it reflects across the x-axis. The negative in the exponent doesn't really, I mean, think about it, what it does, you know? It really just means 1/2 to the x. Right? We okay? No? Okay.
Can you, is it too much to ask to draw before the negative?
No, that's why you gotta do that. All right, we can do it, but what's up, Miss? Miss, I don't even know. Yeah. Take it. Okay. Let's look at this next one. Let's see if we can draw it. You ready? All right, we don't care about that -1 right here, so pretend it's not even there. So I have 2/3, and I have to the negative x. So it's going to grow as x gets larger. Yes or no? But that negative reflects it across this negative. The x-axis. Yeah, I said y-axis last time. It might be my fault. The x-axis, and that +3 does what? Shifts it up 3. So it's going to look like this. Here's the x-axis. Here's up 3. So it's going to look like, something like that. It's approaching infinity. So what is this approaching? It looks like negative infinity. How are we feeling, guys? We feeling okay? I know, miss. All right, here we go. 0.4 to the power x. 0.4 to the power x. Is 0.4 larger than 1 or smaller than 1? Smaller. So as x gets larger, this output needs to be approaching 0, just the 0.4 to the x, right? Because, whenever you take a decimal smaller than 1 and you multiply it with itself, it gets smaller. And then that negative reflects across the x-axis. And then that -4 does a vertical shift down 4. So it looks something like this. Let's see. Looks something like, nope, I already messed it up a little bit. Looks something like that. Man, are all these not going to be, man, I messed up when I typed these out. I should have meant, oh, here's the other one. So this one's going to be negative infinity. Does that make sense, guys? All right, what about this one? It's the same graph. -4. I know today was hard. We just did a whole bunch. If you know 3 graphs, and these are the only 3 you know, you'll be fine. If you know y equals e to the x, if you know y equals e to the negative x, 4 graphs. These look the same, right? So if you know those, and if you know the difference between 1/2 to the power x and 2 to the power x, if you know all those, you will be fine. Because that 2 and that 1/2, I can replace it with 1/3 and 3, 1/5 and 5 to the power x. So, because they're all the same. Cool or not cool? Okay, so from that, see if you can try to figure out these. Notice that in this, I put NC for no calculator. You can check your work after the fact, but notice some of them are the same. See? Do you guys see what I mean? All right, guys, so that's it. And that's what we're going to be working on tomorrow, that activity. I might put, did I already tell you about the UH quiz 3 continuity 1? That we're good for that? Okay, well, I'm telling you now. Don't relax. Don't throw me under the bus. Like, man, Travis is being so unfair. UH quiz 3 continuity 1. You know it all. There's only 10 questions. Attempt by tomorrow. I was going to say today, but you guys look tired. Attempt by tomorrow, and it's due by next Tuesday. Is that okay? I might have put Wednesday on gradebook. I'm not sure what day I put. But yeah. Do I have what? I do. Oh, I have forks. Yeah, miss. Why would you not? Why would I? In the closet. All right, guys. We're done.
Continuity 3 is due by next
Yes.
Yeah, the trig limit 5 is also.
No, wait, with you.